Urinary system, lesson 20. And at the very end,
Oh wait, maybe we should go because
there's a section
she's
on
gonna go on
clinical
a whole
application.
lecture.
All right, so if you're sick, let's say you have the flu and you're vomiting a lot and you're losing a lot of fluid. Do you know what the doctor usually recommends for you to rehydrate?
Gatorade or flat soda.
Yeah, electrolytes, so things like Gatorade. Notice they won't say, hey, just drink straight water. A lot of times they'll recommend some electrolytes. Some other things they might recommend is like saltine crackers, right? Or maybe a little bit banana. These all have sodium and potassium. So when they say, hey, rehydrate with electrolytes, it's really sodium and potassium that we're looking for. And here's why. To understand how sodium and potassium help you rehydrate, we will need to go back and review the concept of osmosis. Okay, so remind me again, what is osmosis? Okay, so what is the movement of water? Good, and from where to where? Yeah, high to low concentration. All right, so what we're going to look at is our urinary tubules. So on the left side of the screen are our urinary tubules. In other words, whatever you put into your tubules is what you're going to urinate out. So this is going to end up in your urine. And what the tubules work with is your blood. All right? So when you drink something, it's going to go into your blood. Right? And then we're going to see how that blood interacts with your urine tubule to see what goes out as urine. Right? So on the right side of my screen is my blood, so this is what I'm going to keep in my body. On the left side of the screen are my urinary tubules, this is what I'm going to urinate out of my body. Right? Okay, so let's say you drink electrolytes, like sodium. Right? That sodium that you drink, it gets absorbed into your blood. Right? So we're going to get a lot of sodium in my blood if I drink electrolytes.
Just a quick question. Does it get absorbed in the stomach or the small intestine?
Yeah, good question. So the question is, does it get absorbed in the stomach or the small intestine? That's actually a digestive lecture, and we'll go through that. All of your major foods and drinks that you consume get absorbed by the small intestine. The stomach only has the ability to absorb water and alcohol and some medication, but the majority of your absorption is going to be at the small intestine, into the blood there. Okay, so you drink your electrolytes, you got a lot of sodium in there, it's gonna go through your digestive tract to your small intestine, then we're gonna put it into our blood. So now the sodium's in my bloodstream, all right? Everyone with me now? All right, so lots of sodium in my blood. Because I have such a high concentration of sodium in my blood, notice my water concentration is going to be relatively low, right? Because I have lots of concentration of salt. Relative to my tubules. Since my tubules don't have as much salt, they're going to have a higher concentration of water. Right? Okay, so take a look at my water concentration. Based on osmosis, which way is my water going to flow? Yeah, into my blood. So in other words, my water, because of osmosis, is going to be retained in my blood. Am I going to have that much water left in my urinary tubule?
No.
No. Am I going to be able to urinate that much? No. Notice my water is retained in my blood, which is, again, rehydrating me. Right? So that's why, again, when you're sick and you need to rehydrate, they say, hey, drink electrolytes. Again, sodium you drink ends up in your blood, causes you to have a lower concentration of water in your blood, which means water is going to move from your tubules back into your blood. Again, you keep the water in your blood, you're rehydrating. So again, less water left in my urinary tubules, less water to urinate out, so you're not going to urinate as much. Questions on that? All right, so where does potassium come in? So potassium, remember, is always related to sodium. You might remember that sodium-potassium pump, right? So if sodium is going to be on this side, by drinking potassium, potassium ends up in your blood. To balance out, if we're going to put sodium in my blood, potassium is going to go in the opposite direction. So it's going to help this pump work. And so if you drink potassium, you're going to be more efficient at keeping sodium in your blood. You'll put your potassium out, and then this causes, again, the retaining of water. Okay, so the potassium and the balance helps, or potassium and the sodium balance out, which is why your best rehydration drinks are going to have a combination of both sodium and potassium together. Sodium alone is great, right, like saline, but the sodium plus potassium is going to be more efficient. And that's why if you look at most Gatorades, most of them will have both sodium and potassium.
So going back to the initial question, how is that relevant in sickness?
How is what relevant?
You retain more water in your blood.
Well, the problem was you're dehydrated, you need to rehydrate, right? So by retaining more water in your blood, you're retaining water in your body, you're rehydrating your body. You're not urinating the water out. Yeah. Right? Okay. Do you guys remember the ratio of that sodium-potassium pump? How many sodiums go across for every potassium? 3 to 2, right? So notice there's always more sodium and less potassium. If you look at any Gatorade or rehydration drink, you'll always actually see a higher percentage of sodium and a lower percentage of potassium. Okay, good. More questions on this?
Just a quick question. You know how they say opposites attract? And the same charges kind of repel each other.
Right.
Is that kind of the same thing in this aspect as the sodium and potassium?
Oh, so the question is, you know, opposites attract, negative and positive attract, and same charges repel. Is that playing a role here? Not necessarily. This is, again, purely based on the pump that can transfer both sodium and potassium at the same time. All right, okay, so one of your discussion questions in the lab is asking you guys to explain, like, why might someone have less urine, or why might you get rehydrated? And this will help explain why you can rehydrate. And when you rehydrate, you urinate less, right? Because you're keeping your water. Okay, so again, this is how you rehydrate with sodium and potassium. This is why things like Gatorade, saltines, bananas, which are high in potassium, why they work really well if you're dehydrated. All right, okay, now let's look at sugar. So sugar affects how you urinate, and you might know this from a diabetic patient. So remember our patient John, who's diabetic? What do you think some urinary symptoms might be of someone who has diabetes mellitus? Do they urinate more or less? More, yeah. So this is the last question in your urinary lab, is asking what is diabetes mellitus, what are some urinary symptoms? So someone with diabetes urinates more frequently. And here's why. What's the problem with sugar with someone with diabetes? Where's the sugar ending up?
In the blood.
Yeah, in the blood, right? We said you have a problem with maybe insulin resistance. You can't bring the sugar into the cell, so the sugar stays in the blood. So let's look at someone with high sugar content in the blood. Okay. So what happens is when you drink sugar, or if you have high sugar content in the blood, either way, we'll learn in our urinary lecture that sugar, glucose, will go from the blood into the tubules, just naturally. Blood to the tubules. So if you were to check a diabetic patient's urine, you would actually find a high content of glucose in their urine. Right? So again, you drink or eat the sugar, it ends up in your blood, and from your blood it filters into the tubule. Okay. So because this person has so much glucose in the urinary tubules, again, high concentration of sugar means low concentration of water relative to the blood. So in this patient, there's more concentration of water in the blood, lower concentration of water in the tubules. So based on osmosis, which way is my water going to go here?
To the tubules.
Which direction? To my tubule. And if it ends up in my tubules, where it's going to end up at?
Urine.
Urine. So in this case, the water actually goes into my urinary tubule, which means I'm going to have a higher amount of water in my urine, which means this person's going to be urinating a lot. And not only will they be urinating a lot, again, you'll find traces of glucose in their urine.
Does that mean it's gonna be more clear or less?
Yeah, so again, if they have more water content, their urine tends to be more clear. They're urinating them frequently and a lot of volume. Okay, so again, that's why, again, diabetics would urinate more frequently. Or, vice versa, if you drink any sugary drinks, that's gonna cause you to urinate more frequently. So, if you actually ask the doctor what's the best drink, they'll say things like Gatorade, but they'll recommend the Gatorade with least amount of sugar, or they'll tell you to dilute the Gatorade. Because Gatorade, if you notice, has a lot of sugar in it. So notice the sugar in the Gatorade is actually going to work against rehydrating you, right? So sugar dehydrates you, and then the sodium and potassium rehydrate. So a best, again, hydration drink would actually have no sugar in it.
So what's an alternative to Gatorade for?
So now they have a lot of different electrolyte beverages out there that actually have zero sugar, or like they have Gatorade, what do they call it? Gatorade Zero, right? So those are going to be better because again, they eliminate the sugar, which is going to work against them, against your
I know a
rehydration.
lot of people say Pedialyte.
Yeah, Pedialyte's another example. Pedialyte tends to have less sugar than Gatorade too. So they'll have the sodium, potassium, but not as high content of sugar. Yep. There's also these other tablets like Noon tablets. Again, they'll have electrolytes, but no sugar. Right, so the trend is now, get your electrolytes, but no sugar. Okay, good. Other question?
A little bit off topic. So is the reason why people have hangovers, is that from dehydration from the alcohol?
Yeah, so hangovers actually kind of goes to the next thing is like we know both alcohol and caffeine are diuretics. We'll explain more in lecture with the hormones that work with it, but these both will make you urinate more, or in other words, they'll dehydrate you. And so a lot of the hangovers from alcohol is because of the dehydration. So that's why they say, hey, after you drink a lot, like the next morning, like rehydrate really well, because just simple dehydration alone can cause headaches. Yeah.
Is that also the reason why some people say that when you drink coffee, their urine smells like coffee?
Oh, when you urinate, or when you drink coffee and you have urine, it smells like coffee?
Yeah.
So that would be, I'm not exactly sure about that. That would be that some of the caffeine molecules itself will filter out and get into the urine if you're actually going to get the scent of coffee in your urine. Yeah, and we can talk about that when we go to the urinary question. All right, so to recap, right, someone who drank pure water, right, no electrolytes, no sugar, so this should be like, hey, the more water you drink, just the more you're going to urinate. Someone who drank salt water, should they urinate a lot or a little?
Little.
A little, right? Remember, electrolytes, sodium help you retain your water. You don't urinate. Gatorade, right? Gatorade has both sodium and potassium. These rehydrate, but it also has sugar, which dehydrates. So again, rehydrate means you don't urinate, you keep the water. Dehydrate means you urinate, you lose the water. So Gatorade, kind of 50-50, right? What about Coke?
Dehydrate.
What's sugar gonna do? Dehydrate. What about caffeine? Dehydrate. So what's that gonna be for your urine? Yep, more urine, right? So you would expect someone who drinks the Coke, because they have two dehydrating agents, is gonna urinate a lot. Right? And then what about someone who drank nothing?
Nothing.
Right? You don't drink anything. Again, at some level, you just need fluid in you to urinate. So someone who drinks nothing wouldn't be urinating that much. Right? Okay, so let's see if we can kind of sum up what we predict. Place these drinks in the order causing the most to least urine volume. Should we start off with Coke being the most and nothing being the least? Gatorade being the most, nothing being the least, or water being the most and Gatorade being the least? What do you guys think? 1, 2, or 3? What's your prediction? Okay, I'm seeing seeing mostly ones and a few twos. Why one? What did we say about Coke?
It has sugar and caffeine, which are both diuretic.
Right? Coke has sugar and caffeine, both dehydrate you, which means both of them are going to cause the most urine. And nothing, of course, should be last. Okay. Right, so one should be the correct order. So we'll see. We'll see if the prediction works out. Remember, this wasn't a perfect experiment. You guys came in already drinking something this morning, so keep that in mind. Right? Okay. Any questions about urinary system? Kind of what we need to know. Okay, so to finish off the urinary lab, so you guys took your first recording of data at time 0. Again, we're skipping the second and third data collection because we're going to be doing a respiratory system lab in between. And you guys are going to come for the fourth data collection an hour and a half later. So note that time you first went to the restroom, and then an hour and a half later, you're just going to go back to the restroom and urinate. Again, you're not drinking again, you're just going to urinate. And then after that, you guys will be able to graph your data. So in this graph, you're going to have basically, you're going to be graphing your volume of urine and your different conditions over your 2 time periods. So you're going to figure out how to get all of that on there, all right? So it's going to be your volume, the 0 time period, the hour and a half time period, and then your 5 conditions of drinks. Okay. Let's now move back to the respiratory system.